This is the third video regarding with exponential and logarithmic function, mainly concerned about logarithmic logarithmic function, and this is the first part regarding with logarithmic function. Okay, let me see what are the logarithms means first. Why we need to learn about logarithms. We know that logarithm is one of the basic exponential, the way of expressing numbers using what exponential statement. For example, as introduction part, let me show you. For example, let's say if we say that a the power of x, it's about logarithm for a fixed positive number b, for a fixed number positive number. It says what a fixed positive number, okay, and b is other than 0, other than 1, which must be different from 1, and for each a greater than b the power of c is equal to a if and only if c is equivalent to logarithm of a to the base b. In this context, we can read logarithm of a to the base b is equal to c. First, why we need to learn about logarithms? From your grade 9 lesson or from previous lessons, we have seen the exponential statement, like a the power of x is equal to, let's say, b, and a is called the base and x is the exponent and b is said to be the product or the final number. In this context, we have three numbers, okay, the base, the exponent, and the product. How can we express each number based in calculations using different types of we need to find the exponent x and we need to find the b, right? From this, as a is the base, this is called what? The base. X is exponent and b is the product, simply product. Therefore, how can we find the different calculations or different equations to find the three numbers: the base, the exponent, and the product b? As we know that to find the product just multiply a how many times? A times. For example, let's say that a the power of x can be written as a times a times a times and times what? A. This means how many times? We need x times, and this is the whole. Finally, we can find out what the product. This is equivalent to b. This is the way to find the product. This is the way of finding the product. How can we find a if b, the product and the exponent are given? Meaning the product b, and the exponent x are given. How can we find the base? For the first one, if the base and the exponent are given, how do we find b? Just multiply a how many times? X times. Just directly multiply a as much as possible to the number of x times. So in this case we can find b. How can we find the other option? How can we find a if the numbers b and x are given? For example, let's say 4 is equivalent to let's say x the power of 2. For example, let's say we need to find this x, okay? We need to find. How can we find out this one? Just we can take it the square root of both sides, meaning if we find the nth root of let's say this one, the nth root of a, or let's say this is x, since our exponent is x, let me say this is x, the x root of, let's say this is b, because we are finding what? The base. The x root of b is equivalent to what? This is a. In short, for example, let's say the square root of 4 is equivalent to, which means because 2 square is how much? Let's say that the cube root of 27 is equivalent to, again, 3. We can say that this means this 3 is our base. These numbers are our bases. This is also what? Our base. But how can we find the number x, or just simply the exponent? How can we find the exponent? We know how to find b, the product. We know how to find the base already. We know we can use the nth root of the number b. So this means the way of finding b and the way of finding a is known. How can we find the number x? How can we find it from the three numbers? Okay, if the product is given and the base is given, how can you find this x? So in this context, we have to use the logarithms. Okay, the logarithms. For example, let's say this is equivalent to log b. Our base is how much? A. Let's say log a is equivalent to, we can write x. The logarithm of b to the base a gives what? X, which means how many times we should multiply a to get b. Means it's not by how much number we have to multiply, but it says what? How many times we multiply the number a to get the product b. Our answer is x, because a the power of x is equivalent to b. This is the way of, or the use of logarithmic functions. Why we have to apply it, how to find the exponents from the base and the product. In general, we can say that if for a fixed number, positive number, number b, which is other than 1, which means you never be 0 as well as never be 1, and for each a greater than 0, for a positive number a, b the power of c is, if we say that b the power of c is equal to a, means our base is, in this context, b, the product is a, and the exponent is c. We need to multiply b c times, and finally we get the product is equal to a. This will happen if c is equivalent to the logarithm of a to the base b, which means our base is b and our product is a, and the exponent is how much? C, which means we need to multiply b how many times? C times, to get what? A. And this is a way of finding the logarithmic statement. Previously we have seen the how we have expressed how to, or why we need to learn about logarithms, just in from the three numbers. Okay, from the c numbers, as let's we take this one, b the power of c is equivalent to a. This is the product, this is the base, and this is the exponent. The way of finding a is just multiply b how many times? C times. Just to find the base b, just we need to find the c root of a, which means c root of a. If c is n, we can say the nth root of. If c is 2, the square root of. If c is 3, we have to say about the third root of. The c root of a gives how much? B. Don't forget, b should be positive and different from 1. The reason why we choose the number b is positive, different from 1. We know that 1 the power of 100 is equivalent to 1, which means the value of a is fixed number, that must be what? Always 1, whatever the value of. So in this context, to express another numbers, b should be different from 1, and a should be positive number. Why it's positive number? What will happen if our base is negative? Since it is positive, actually it must be 1 positive, and c is positive, or any number, it can be out any real number, this number must be what? Positive. For example, say if c is any real number 1/4, which means the number, this number is even, so the fourth root of the fourth root of a to be what? A real number. Yes, to become what? A real number, a should be positive number. In this context, this should be what? Every positive, it must be what? Every positive number, because it contains what? The even numbers, or the even root of a. Even root of a. For example, let's say, let us see, if 3 to the power of 4 is equal to 81, 3, if we multiply 3 how many times? 4 times, then our answer is how much? 81. Then if we want to express this statement as a logarithmic statement, which means it says what? Log 81 to the base 3 equivalent to how much? 4. 3 to the power of 4 gives how much? 81. Or in other words, how many times we should multiply 3 to get how many times? How many? 81. And our answer is 4, which means 3 to the power of 4 gives 81. To read, logarithm of 81 to the base 3 is equal to 4, just like this. Logarithm of 81 to the base 3 is equivalent to 4. This is the way of writing logarithms. Okay, let's see some examples. Example 1. Express the following as logarithmic statement. Okay, logarithmic, it's messy what? Logarithmic statement. Logarithmic statement. Don't forget that to express the numbers that we have to write the expression of logarithm is to find the exponent. So from this, from a, our base is 4, our exponent is -3, and final product is 1/64. So this can be written as a logarithmic statement, log 1/64. Okay, we can put inside the bracket to the base 4. Our base is how much? 4, and our exponent is how much? -3. By the way, don't forget that the exponent can be any real number. Okay, any real number. It can be any real number. Only the limitations should be working for only bases and the products. For the products, for this one, our base is 125, and the product is 5, and exponent is 1/3, which means logarithm of 5 to the base 125. Okay, our base is how much? 125, and the number is 5, gives 125 the power of 1/3 gives how much? 5 times. So it can be written as 1/3. Logarithm of 5 to the base 125 equivalent to 1/3, which means 125 the power of 1/3 gives 5. For the third part, which means 8 the power of -2/3 gives 1/4, which means logarithm of our product is 1/4. Yes, 1/4 to the base 8 is equivalent to the exponent is -2/3. This is our final answer. The second example, expressing the logarithmic statement into exponential form. Yes, we need to express the logarithmic statement into the exponential statement type. So for a, the logarithm of 1/64 to the base 4, already we have expressed in the previous example. This means our base is 4. Yes, 4, which can be written as 4 the power of, it can be written as, or it should be what, the different statements. We can use what, the arrows. 4 the power of -3. This is equivalent to our product is 1/64. It can be written as 4 the power of -3 equivalent to 1/64. For this part, again, we can write this means 10 the power of, it will be arrowed, 10 the power of, this our base is 10 and exponent is 1/2. 10 the power of 1/2 is equivalent to our product is this one. It can be written as square root of 10. So these are the way of expressing logarithmic statements into exponential forms. The logarithmic statement, the number after sign is the exponent. Okay, let me see what are the laws. Since we know there are some laws regarding the exponential function. Let's say, for example, to remind you, a/b, the power of n can be written as a the power of n over b the power of n. This means the individual the can be equivalent to the individual exponents. So as this is the law of exponential, the logarithmic statement has also its own laws, or it has its own properties. Let's say the statement: if b, x, y, a, and c, we have to express, or we have to state the numbers in the form of logarithmic statement. 1, 2, 3, 4, and 5 numbers. All are positive real numbers. Okay, positive. It must be what, all should be what, positive real numbers, and the bases. Let's say the bases b and a are the bases, some bases, which means a and b are different from 1. Don't forget that the bases should be different from 1, and all the numbers must be positive, since it does not contain the number 0, so it must be what, positive numbers. The logarithm of xy to the base b can be written as the individual logarithm of x and y with the same base. Logarithm of x to the base b plus logarithm of y to the base b. This statement can be easy to make it what, those numbers are very simple. For example, let's say logarithm of 16 to the base 4 can be written as, 16 can be, we know that 4 times, or just 2 times 4 times 4, so we can write logarithm of 4 to the base 4, since 16 is 4 times 4, plus logarithm of 4 to the base 4. So this is 1 and plus this is again 1 plus 1 is finally 2. The logarithm of 16 to the base 4 is for the power of something for the power of x, let's say 16. This means x is equivalent to, which is the same as previous this one. So it can be written as the sum of the individual logarithms, the sum of the individual. Okay, in the case of quotient, logarithm of x over y to the base b can be decomposed as the difference of the two numbers or individual logarithms, which means log x to the base b minus log y to the base b, which is similar to the quotient of exponential statements. To see the for example, by to mention the examples, we can express this one. Let's say logarithm of 32 over a to the base 2. It can be written as, this means logarithm of 32 to the base 2 minus logarithm of a to the base 2. It can be, this is equivalent to 5 and this one is 3. 5 minus 3 is 2. Let's see the quotient by dividing. 32 over 8 is equivalent to 4. Yes, it can be written as, let's write to logarithm of 4 to the base, which is 2, because 2 to the power of 2 is 4, which is similar to 5 minus 3. The third law, the logarithm of x to the power of k, the product has an exponent, extra exponent with the base b is equivalent to, we can take this exponent as product, since we are multiplying the product by the k times logarithm of x to the base b for any real number, whatever the value of k. It can be multiplied with the as, or can consider as a quotient of the logarithm without changing the product and the base. The other one is the logarithm of b to the base b. For example, let me give you an example for this one. Let's say logarithm of 5 squared to the base 5 can be written as twice of log 5 to the base 5. This is 1 and this is 2 times 1 is finally 2, or just simply 5 square means 25. 25 can be written as 5 square. Okay, so this is the same as for the fourth part, the logarithm of v to the base b, the same product with the base can be 1, because this means b to the power of 1 is b itself. Okay, that's what the reason the logarithm of b to the base b is equal to 1. The fifth one, the logarithm of 1 to the base b. Don't forget b is the other than 1 and it's multiple positive number. The logarithm of 1 to the base b is equivalent to 0. The reason why, as we know, the law of exponents, a number to the power of 0 except the base is 0 is equivalent to 1, which means b the power of 0 is 1. That's why the sixth part, if sometimes the logarithms does not work easily, we can decompose into another basis. The logarithm of c to the base a can be decomposed as the logarithm of c to another base b. Okay, you have to change the base over the logarithm of a to the base b. This one, a is the base for the first statement and c is the product for the first statement, and b is any number other than 0 or other than 1, which is our positive number. For example, let's say if we want to decompose this one, the logarithm of 4 to the base 8. In this context, it is difficult to find or difficult to express the number 8 and the number 4 as exponential statement. This means we know that, let's say this is, if it says x, 8 the power of x gives what? 4. In this context, there is no any direct relationship between the number 8 and the number 4 based on the exponential statements. But we can express this one, logarithm of 4 to the base 2. We can make it any basis other than 1, and the base should be positive number, divided by logarithm of 8 to the base 2. By the way, don't forget that the bases should be what? The same base. Okay, when we express the number. So this can be written as 2 over 3. Finally, the number 8 the power of 2 over 3 gives what? How much? 4. It can be decomposed as into this one. This may be what very important for changing the bases. Okay, changing bases, the bases. For example, let's say, how can we solve this kind of statements? Logarithm of 4 to the base 5. It's difficult to find out this one, to find by using what any numbers, but we know that this can be a real number. To express the number 5 as product, x gives 4 it's difficult, it seems too difficult to find easy, but we can decompose into what? Logarithm of 4 to the base 10 over logarithm of 5 to the base 10. In this context, it will be very simple. This statement, the b the power of, okay, the exponent should be what? The logarithm statement with the base b. B the power of logarithm of c to the base b is c. Just this can be what? Base should be what? Similar. This can be 1 times c is, it gives what? C. The reasoning is why, if we say that let's say log c to the base b is x, for example, let me say this is x, then to express as a base type or exponential statement, this means b the power of x gives how much? C. So from this, the logarithm of c to the base b is, let's say this is x, so b the power of x means it's equivalent to, again, what? C. That's why we have to make it the logarithm of the b the power of logarithm of c to the base b is c itself, the product itself. B should be what? The same as with the base. Let me see some examples regarding with logarithmic simplifications. The logarithm of the third root of a to the base 1 over 4 plus the logarithm of radical a to the base 1 over 2 minus the logarithm of radical 32 to the base 1 over 2. This can be written as we can express logarithm of a to the power of 1 over 3 to the base 1 over 4 can be written plus the logarithm of a to the power of 1 over 2 to the base 1 over 2 minus logarithm of 32 to the power of 1 over 2, since it's radical we can change it into what? The exponent form, just like 1 over 2 to the base 1 over 2. We can simplify this one. This means 1/3. Okay, it can be bring it 1 to the power of 3 to this, or just we can write what? We can convert just all the numbers into the same base type. This can be written as 1/3. Okay, 1/3 times log a to the base 1 over 4. Yes, plus the logarithm, we can write again 1 over 2 here, the logarithm of a to the base 1 over 2. Yes, minus logarithm of, we can write again here 1 over 2 logarithm of 32 to the base 1 over 2. This one, it can be written as or let's say 1 over 3, the whole the power of this can be written as a the power 1 over 4 the power of 8, 1 over 4 the power of x gives 8, which means let's simplify over here. 1 over 4 the power of x gives 8. We can change it into what? This number, it can be written as to the power of minus 2x, because this number can be expressed as to the power of negative 2x, or just simply to the power of negative 2 the power of x smaller, means which is to the power of 3, right? So this means negative 2x is equivalent to 3. Just you can write it by dividing negative 2. You can get what? Negative 3 over 2. So this can be written as negative 3 over 2 plus 1 over 2 times, this can be written as 1 over 2 the power of x gives 8 is just simply negative 3. Okay, which means 1 over 2, let's write over here, to the power of negative 1 the whole the power of x gives to the power of 3, because 8 means to the power of 3, and it can be 1 over 2 can be turned to the power of minus 1 minus x, which means minus x equal to 3. This implies that x is equivalent to negative 3, so it can be as negative 3 minus 1 over 2 times, again this can be written as negative 5, because to the power of 5 is 32, since it is our base is negative fraction, it can be negative. So from this, this can be written as negative 1 over 2, yes, minus 1 over 2 times 3 is minus 3, minus 3 over 2, and negative times negative is plus, so it can be written as 5 over 2. So from this, minus 1 minus 3 plus 5 divided by 2, since the LCM of the denominators are 2, so it can be equivalent to, can be written as negative 1 minus 3 is minus 4 plus 5 is 1. It can be, finally it can be 1 over 2. The simplified form of that statement is 1 over 2. It must be, it says a, but it must be b. okay, it must be b. This is the negative of logarithm of radical 32 to the base 1 over 2 plus the logarithm of third root of 64 over 60 to the base 2. So this can be written as or just simply let me show you something. 1 over 2 means the negative. If we say that log b to the base a square, what will happen, or what can be changed if we wanted to transfer this exponent to the base b, or the number b? What should be? It must be, in this context, the base is a square. Okay, so if we want to express as exponential statement, a the power of 2, let's say the whole the power of x, a number base, this is the base, gives how much? B times. This means a the power of x the whole the power of 2. We can exchange the place of the number 2 and the number x, gives b. So it can be taking the we are finding, or we are removing the number 2, just taking the square root of both sides. So a the power of x gives radical b. From the logarithm statement, if it says a square, when we change the number 2 into b, it can be changed what by using or by making the number b radical. So in general, you can say that the logarithm of b to the base a the power of n can be written as logarithm of the nth root of b, okay, the nth root of a to the base b, or just simply we can bring it 1 over n times logarithm of b to the base a. We can bring it the exponent of the base into the front, and by making what its reciprocal. So from this 1 over 2 means to the power of minus 1, okay, to the power of minus 1, and the exponent can be over here. So negative the logarithm of 32 to the base is 32 to the power of 1 over 2. Since this square is square root, means just we can make it 1 over 2 plus logarithm of, we can simplify this number easily. 64 over 60 means it's 4, right? Third root of, or 4 the power of 1 over 3 to the base 2, to the base 2. So this can be written as, bring it 1 over 2 to the front of the logarithm, negative of 1 over 2 times logarithm of 32 to the base 1 over 2 plus, again bring it 1 over 3 to the front of the logarithm, 1 over 3 log 4 to the base 2. So from this, negative 1 over 2 times the logarithm of 32 to the base 1 over 2 is just simply negative 5, okay, negative 5, because 1 over 2 to the power of negative 5 gives 30 plus 1/3 times the logarithm of 4 to the base 2 is 2. This means negative times negative is positive, so 5 over 2, 5 plus 2 over 3. Our LCM is 6, because the base are 2 and 3 different numbers. 6 divided by 2 is 3, 3 times 5 is 15, plus 6 for 3 is 2, 2 times 2 is 4. So finally it is equivalent to 19 over 6. It cannot be simplified, just our final answer is 19 over 6. Again this could be C. The logarithm of 27 to the base 12 times logarithm of 4. By the way, at the beginning, before we are seeing the logarithm of 4, there is a common logarithm. If we said logarithm of x to the base 10, it can be just, since our number base is 10, and just basically we are using the base 10 numbers, just you can write log x simply, because no need of writing the number 10 as a common logarithm. So log 4 means we have base 10, again we have base 10 over here, times the logarithm of 10 to the base 3. How can we simplify this one? By the law of logarithm, we can write this number log 27 to the base 10 divided by log 12 again to the base 10 times, this can be written as, since this is the sum, we can mix by using the product rule. 4 times 3 is 12, so it can be written as logarithm of 12 to the base 10, okay, no need of writing actually, times, it can be written as a logarithm of 10 log 10 over log 3 simply. It's log 3. So this can be simplified 1, and this becomes what, 1. Since log 10 is 1, which because log 10, we know that log 10 to the base 10. As we know, log b to the base b is 1, so log 10 to the base 10 is 1. So finally we left log 27 over log 3. Since our base is 10 10 in both cases, we can mix it into what? Log 27 to the base 3. Okay, we can mix it. By the way, don't forget that if we go forward, we come back again backward in the case of calculations. So logarithm of 27 over logarithm of 3 can be decomposed or can be mixed as logarithm of 27 to the base 3, and this is equivalent to 3 the power of something gives 27 is how much? 3, because 3 the power of 3 is how much? 20. This is the way of simplifying. Okay, the fourth example: 16 the power of log 3 to the base 4 plus 2 the power of 1 minus log 4 to the base 2 minus 5 the power of log 49 to the base 5. We know the rule b the power of log c to the base b is c, so we have to apply this one. This can be nice, and we left c. But in this context, the base for the exponent of logarithm is 4, but the normal base is 16, so we have to express as a similar number. So this can be written as 4 square the whole the power of log 3 to the base 4 plus, since exponent form a the power of x minus y is x the power of a the power of x over a the power of y. This can be written as to the power of 1 over to the power of log 4 to the base 2, again minus simply this can be written simplified, and we left only what? 49. This is minus. So from this can be written as 2 can be 4 the power of twice of log 3 to the base 4, yes, plus, which means 2 over, again this can be simplified, and we left only 4 minus 49. Let me take this one. For the power of twice of log means 4 the power of log 3 square to the base 4, yes, plus 2 over 4 can be simplified, 1 over 2 minus 49. This means 3 to the power of 2 is 9, so this can be written as 4 the power of log 9 to the base 4 plus 1 over 2 minus 49. This is cancelled, we left 9 plus 1 over 2 minus 49, so we can make it over 1 here, or just simply 9 minus 49 is 4 minus 40 plus 1 over 2. We can simply minus 40 plus 2, this is multiplied by 2, minus 80 plus 1 over 2 is equivalent to minus 79 over 2. The simplified form of this statement is, finally we can make it equivalent to negative 79 over 2 minus 79 over 2. Okay, let's continue this one. This can be written as log 27 to the base or the power of 1 over 2 to make it what? 1 over 4. This means there is no any relationship between the number 4 and the number 27, so we can write this number 1 over 2 times log 27 to the base 1 over 4 to the base. Since this number can be written as, again it can be written as this is 3 cube, or there is no any relationship between the numbers, so we can make it 1 over 2 times logarithm of 27 over logarithm of 1 over 4. Okay, we can make it this one just like this. If you want to go further, just we can reach 1 over 2 times log 27 over the logarithm of this means log 1 minus log 4 with the base 10. Okay, we can go, this one is negative number, so it can be written as let me bring it over here, 1 over 2 times log 27 over negative of log 4. So this can be written as the negative of 1 over 2 log 27 to the base 4, the negative of. You can make it this one. This should be inside the bracket. Finally, we can make it what the negative of this value, since then there is no any relation between the number 4 and the number 27. We have to express just like this. So from this, we can write this number like log 16 to the power of 1 over 2 to the base 4 minus log 2 to the base 4. This can be written, bring it over here, 1 over 2 times log 16 to the base 4 minus log 2 to the base 4. We have to make it, this one is only for this bracket, it's only for this one, no need of this bracket. So this can be written as 1 over 2 times the logarithm of 16 to the base 4 is 2 minus, this can be written as the logarithm of 2 to the base 4 means we need to multiply how many times? We have to multiply 4 to get the number 2. It can be written as 1 over 2, because the square root of 4 is 2. So this means it's equivalent to 1 minus 1 over 2, which is equivalent to 1 over 2, the final answer. Or just we can mix it. Okay, we can mix it by using the logarithm. This can be written as, since our bases are the same, this can be logarithm of radical 16 over 2 to the base 4. Okay, to the base 4. Since this is minus, we can mix it, since we have the same bases. This can be written as logarithm of the square root of 16 is 4 over 2 to the base 4. This is logarithm of 4 over 2 is 2, just to the base 4. This is equivalent to 1 over 2. Let's we do this one. Previously we have mentioned that log b to the base a square can be written as 1 over 2, or just simply this can be written as just with the log, it can be written as log b to the power of 1 over 2 to the base a. This exponent can be transferred to for b by making what roots. So this means we can make it what log 5 the power of 1 over 2, again the whole the power of 1 over 2, this 1 over 2 derived from this one to the base 3 plus logarithm of 3 times 5 the power of 1 over 2 to the base 3 minus logarithm of 6 to the base 3. Since we have the same bases, we can mix it. Okay, we can mix. This means 1 over the power of 1 over 4 logarithm of 5 the power of 1 over 4 times, which means 3 times 5 the power of again 1 over 2 divided by since this is minus, it can be divided by what, 6 to the base 3. These numbers should be inside the bracket. So finally we can write this one, logarithm of we can add this, okay, or just simply by 3 1 by 3 2, logarithm of 5 the power of 1 over 4 plus 1 over 2, yes, divided by 2. These are the exponents. Okay, exponent to the base 3. This means this can be written as multiply by 2 in order to add. Logarithm of 2 plus 1 is 5 the power of 3 over 4, yes, over 2 to the base 3. We can put as it is, or just simply it can be written as logarithm of, or 5 the power of 3 over 4 minus to the base 3 actually, minus logarithm of 2 to the base 3, and bring this one to the front. We can simplify 3 over 4 times logarithm of 5 to the base 3 minus logarithm of 2 to the base 3. It can be simplified just like this. Actually this can go further unless if you didn't find the logarithm of 5 and logarithm 3 by using the common logarithm. Okay, the next video we'll see the additional examples related with the logarithmic, specifically simplifications. Don't forget to share and subscribe to your friends. to get the more videos regarding these such kind of lessons, please subscribe.